As you may have guessed, constant memory is memory that will not change over the course of kernel execution, and as a result, it's very useful for things like lookup tables or fixed parameters that you need to pass into some models, so data that will not change. And it also has grid scope and application lifetime, and it also resides in device memory. But you remember those red arrows that I showed on the architecture slide? Well, the reason I had them there is that even though constant memory resides in device memory, it's actually cached in a special location called the constant memory cache, and that's what actually gives it the performance increase. Essentially, constant memory is constrained in size. You're typically looking at 64 kilobytes that you can use to store the constant data that you need to operate on. And actually, operation on constant data is very similar to statically defined device memory. So you declare it on the global scope with the constant modifier, and then you just use it freely within the kernel. And once again, you use a CUDA memcpy to and from symbol to copy to and from the host memory. And constant memory is fast. It's very fast, and it's optimal when all threads read from the same location. And by the way, constant memory is also something that's used for kernel arguments. When you provide those angle brace parameters to the kernel, constant memory is used for that. And texture memory, which is also very similar to constant memory, it's actually a kind of memory that's optimized for 2D access patterns, so something that would relate to textures. And this is something that, you know, is more likely necessary for game developers and people like that, unless of course you're doing some computation on graphics, in which case it might be worth looking at it as well.